So we will see about yield of tube well example problem. So a tube well fully penetrates on unconfined aquifer. Calculate the discharge of the tube well from the following data. Diameter of the well is 15 centimeter. Drawdown is 4 meter. Length of the tube well strainer below the drawdown is 10 meter. Coefficient of permeability of aquifer is given as 0.05 centimeter per second, and the radius of circle of influence is equal to 200 meters. So again, beware of the units. Okay, so okay, so before that, you just kindly make hold the video for a while and then just check out the recall everything related to what is unconfined aquifer and what is meant by drawdown, what is the where exactly the length of the tube will strain below the drawdown exactly, and what is meant by aquifer, and the formula and how the formula is arrived. Okay, so you can just check out our previous video or else the classwork note, whichever I have provided to you, and then come back to the problem. Okay, so now here that the k, I mean k is given as 0.05 centimeter per second. That is a coefficient of permeability of aquifer, and s is given as 4 meters, so that is a drawdown, and h, small h, is the length of tube well strainer below the drawdown, which is a 10 meter, and which is taken as an effective length, and r, small r, is 7.5 centimeters. So don't ask me where the small r 7.5 centimeters came from. So that is from diameter of the well, so it is a radius. Okay, and the next radius of circle of influence is given as 200 meter. Okay, so now you are knowing about the formula, that is q is equal to 1.36 ks into s plus 2h divided by log the base 10 into capital R divided by small r. Okay, so before going to the solution part, you can recall it. Okay, so here it's for the unconfined aquifer, it is given the h is equal to height of this static water level from the impervious layer, q is the discharge of the well, s is the drawdown, and h is the depth of water in the well from the point of maximum drawdown to the top of the impervious layer, and r is equal to radius of circle of influence, and r is the radius of well, and o is the point, a point considered as origin. It is the point on drawdown curve with the coordinate xy. So you can see where s is, and capital H, small h, r, and the static water impervious layer. So you can just note down and also try to recall these parts, how it has been derived and taken. Okay, and then you can move on to the solution. So now you mind with the unit, so everything you are supposed to take it as meter cube per second, right? And convert whichever is given in a centimeter or some other units, convert it into in terms of a meter, and now you can substitute it directly and get the value in terms of meter cube per second. And I hope that you're knowing to convert it into liters per second. So this conversion is already given in the hydraulics, as I know. So I hope that you can convert it into the liters per second. If you're having any doubt related to how that is being converted, if you forgot or something like that, then let me know. I will again tell you how to convert it. Okay, so because conversion is more important. Okay, so now what you can do is that instead of h is equal to 10 meter, take 12 meter, and instead of diameter of the well as 15 centimeter, take 16 centimeter. Okay, and draw down as 4.5 meter, and radius of circle of influence as 220 meter, and remaining you can keep as such, and try to work out the problem. So moving on to the second problem, a tube well of 30 centimeter diameter penetrates an unconfined aquifer. During the pumping test, following data was obtained. So height of the static water level from the bottom of aquifer is 50 meter, and height of the drawdown from the bottom of the aquifer is 45 meter, and the radius of the circle of influence is 300 meter. Coefficient of permeability is 50 meter per second. So now you can calculate the discharge of the well. So here that R is given, capital R, that is 300 meters, that is the radius of circle of influence, right? So and tube well diameter is given 30 centimeters. Now you can convert it into radius and in terms of meter, and H is given as 50 meter. And the small h is given as 45 meter, and you can apply it to the same formula as mentioned earlier and try to find out the value. So this formula already we have saw in the given derivation. That is 1.36 k into h square minus h square divided by log to the base 10 r by r. Okay, and you can find it out, and keep in mind to have the values in terms of meter and then calculate it and find it in terms of meter cube per second, and if possible convert it into liters per second. Okay, so next problem. Okay, so I can have give you a workload here. So instead of instead of radius of circle of influence of 300 meter, take it as 250 meter. Remaining you keep the things as such. Okay, so next we have a tube well penetrates fully into a confined aquifer. The following data was collected during observation. Calculate the discharge of well. Radius of tube well is equal to uh, 20 centimeter, thickness of a confined aquifer as 25 meter, and drawdown is 4 meter, radius of circle of influence is 300 meters, and coefficient of transmissibility is 125 into 10 power minus 4 meter square per second. So find out the coefficient of permeability. So you can hang out the video and check out what is a confined aquifer here, and what are the data is given. So here, in the height, check out where the height is, and yes, h b t. So read it once again about the drawdown, about the radius of circle of influence, and height, static water level, and where is a confined aquifer, other data t, right? So you can just check out and verify, and also recall the formulas and other things. That is a coefficient of transmissibility is given by t is equal to kb. Okay, and also q discharge is also given. So recall it once again with the previous, either with the previous video or else with the given classwork note, and then you can move on with the problem. So again, the coefficient of transability is given as t is equal to k into b. So k is equal to t by b. So you're knowing about the b. What is b here? B is 25 meter. That is the thickness of the confined aquifer, and t is your coefficient of transmissibility, and you can find it in terms of meter per second. And coefficient of permeability, you got it in terms of meter per second, and then the discharge. Okay, discharge is 2.72 k into b is divided by log to the base 10 r by r. Okay, and you can just convert it, and you will get it. Keep everything in terms of meter and find the value. So here the discharge, here the well is given in terms of radius of well is given in terms of uh, centimeter. So here the radius of tube well is given, so it's not the diameter, so you can take it as such. Okay, so read the question properly. Okay, fine, and you'll get it in terms of meter per second when you find a discharge, and if and then you can convert it into liters per second. Okay, so if you have any kind of doubts with the conversions and all other things, then you can just approach me, and I'll just tell you how to convert it. And Next, we have a tube well penetrates completely confined aquifer. Determine the diameter of the tube well from the following data. So required yield is 100 liters per second, and radius of circle of influence is 200 meter. Thickness of confined aquifer is 330 meter, and the drawdown is 5 meter, and coefficient of permeability is 60 meter per day. And you know the formula, and you can substitute it as such and get the value, and it's a direct substitution. Okay, so here the main important thing is that converting into uh, meter per day into meter per second. So you're knowing 60 is one that divided by 24 into 60 into 60, so per day into in minutes and seconds. Okay, I hope that you're remembering all these things, right? So you can get it as a meter per second. Okay, so and then you can find the radius. Okay, so and with that you can find the diameter of the well, right, in terms of anything meter or centimeter, anything will do. Okay, so what you can do is that again here the radius of circle of influence alone you just convert it into 250 meter, and you keep reminding things as such and try to work out the problem. Okay, and also the coefficient of permeability, you take it as 55 meter per day. Okay, so that's a changes here, nothing else, and you can keep as such. And for the problem number 3, you converted the radius as 20 centimeter, take it as 25 centimeter, and keep remaining things as such. Okay, so try to work out the problem.